So on this one, we're going to be talking about the area of a triangle. And for the most part, I'll be using the symbol of a triangle. So I'm just going to draw some generic, nothing special about the triangle type of thing. So the area of a triangle, again, I'm going to kind of put this in terms of a parallelogram, or a rectangle, or a rhombus. So if I go back and draw a parallelogram, which I know is base times height, any triangle can be formed by taking half of it. So what I'm actually doing is I'm taking half of the area of a parallelogram, or half the area of a rectangle, or half the area of a rhombus. So the formula for the area of a triangle is 1/2 the base times the height. So again, the height and the base have to be perpendicular. So that whole piece is going to be the base. The reason why I chose to do this in a separate video is because there's several different types of triangles. If we specifically have already a right triangle, and that's all we have, and it says find the area of the triangle, and you're thinking, well, I don't have a height. But remember, the base and the height are the two pieces that are perpendicular. So there's my perpendicular. So that means this is either my base or my height. And that's the other one. So this would be 1/2 base times height, which would be 1/2 times 5 times 12, which gives me 1/2 of 60, which gives me a measurement of 30. One thing I didn't mention in the other videos is, remember, area is square units. I did not mention that. Area is square units. Because what we are doing is, if we have this kind of a figure, we are looking at not lineal, so not going around. We'll talk about perimeter here in a little bit. But we're looking at how many squares can I fit in here? Like if I were laying tile or something like that. Tile or carpet is what I usually think of. Okay, and we also have another kind of triangle that you might see, and that would be something more like this. For some reason, obtuse triangles kind of throw people for a loop. Kind of reminds me of the parallelogram or the trapezoid where the height can kind of float. So if this is my base, then I need a segment that is perpendicular to that, which is way out here. And then again, here's my height. Do not count this as part of the base. Not part of base. But your formula is still the same. It is 1/2 the base times the height. The last one that I want to cover has to do with an equilateral triangle. So in an equilateral, we know that all the sides are equal. So if I make this have a measurement of 8, then all of these have a measurement of 8. And I'm going to note that this is an equilateral. Well, none of the sides form a right angle, so these can't be my base and my height. I don't have anything else drawn there. So we can draw the piece that goes from any of the vertices perpendicular to one of the sides. So that means this is going to be my height. What you need to know is that this is also called the altitude. So the altitude in an equilateral or isosceles triangle cuts or bisects the base. So in other words, if it bisects, it's cutting it into 2 equal parts. So if this whole thing is 8, that means this little piece is 4, and that little piece is 4. So that might be something that you're going to need to know for what we are doing. And if we're still looking for the height, this forms a right triangle. So we can go right back and figure out what the height is by using the Pythagorean theorem. So the height is going to be a leg. So the height squared plus my other leg squared, which is 4, equals my hypotenuse squared. So h squared plus 16 equals 64. H squared equals whatever 64 minus 16 is, which is 48. Solving for h, so we're going to square root both sides. So h is going to equal approximately 6.93. So here's one where we're not given the height, but we do have enough information to actually find the height.